all the way back. We all mixed up from
afternoon, everyone. So it's my pleasure to announce today's speaker, Dr. Grace Huang, who received her bachelor from the University of Toronto and then her PhD. And she's now working at Rock Science Incorporated in Toronto as a product manager. So please, Dr. Huang, take it away.
Okay, thank you, Dr. Lee, for the introduction. Good afternoon, everyone. My name is Grace, and I'm currently a geomechanics product manager at Rock Science. We're based in Toronto. So I guess most of you may be more familiar with engineering consulting. For this presentation, I want to discuss a different side to engineering, specifically in the software sector, and how engineering analysis the software are developed, who are the people involved, and what kind of skills can be brought into that side of the industry based on what you're learning in graphics. Okay, so back in 2019, I finished my PhD dissertation. It was on designing column-supported embankments. So this is used in transportation infrastructure, and then there were gaps in the design methodology. And one of these gaps I was trying to address had to do with embankment therapy. So I used 3D finite difference analysis to look at the different ways this type of embankment can fail. We found that the mechanism can be quite complex. You can have bending failure in unreinforced concrete columns. You can have shear through the soft soil in the foundation. And there could be tensile rupture in the geosynthetic reinforcement that can often be installed at the base of the embankment. So because my dissertation was in the design of a type of transportation infrastructure by natural progression, and then moved to an engineering consulting firm that deals with transportation infrastructure. And it's called HMTB. So this company is based primarily in the United States, and it has many offices across the country. And so personally, I was based in New Jersey, about half an hour from New York City. So when I say this firm does work in transportation infrastructure, and I mean all aspects that are listed here. And as a result, geotechnical engineering is really an essential supporting service in this firm. So some of the geotechnical services that I perform. First, we have foundation engineering. So this is the design of shallow footings, piles. I calculated lateral earth pressures for earth retention systems, as well looking at the stability behind these walls. Now, for earthquake engineering, obviously this is more prevalent in the West Coast, but if you're doing work, let's say in central United States or on the East Coast of the United States, this could come into play depending on the site classification. I also did work in ground control, and this means improving the quality of the in-situ soil, such as introducing cement by soil mixing. I was involved in site exploration, characterization. So simply put, that's field work. You have to be on site to understand the earthen materials you're working with. And then underground engineering. So we looked at tunnels. Embankment engineering, which is used in your highways and railways. And obviously you need to mitigate instability in rock slopes that may be bounding your infrastructure. So all of these projects, it was really important to use a combination of field testing, laboratory testing, and finally analysis to make informed design decisions. And obviously for every project, you had to follow the appropriate and relevant design standard. So in this photo, on the top right here, I'm showing various types of samplers. So you have the split spoon, that's a Shelby tube, there's a triple core barrel, and I think that's the outer casing of a Denison. So as a geotechnical consultant, you had to make decisions on what type of samplers and equipment to use in the field to get the best information possible. You also had to make decisions on how many boreholes you want at the site, where to make these boreholes, and how deep they should go to get the information you need to proceed with design. Now, after collecting samples from the field, you had to take it to the lab sometimes to perform additional testing to get strength parameters relative to your analysis. So here I'm showing you an uncompliant compression test sample. So this is actually a soil cement mix. And for these kind of samples, uncompliant compression is a typical test procedure. Now, once you've collected all the data about your site, you then can move on to analysis. And in this case, I'm showing you a rather complex 3D numerical model. So you would have to interpret your material parameters from the field and lab testing. And then work with collaborating engineers, and they may be, let's say, structural engineers, to decide on the geometry to use for the model, any assumptions on various load cases to analyze, as well as assumptions on the boundary conditions. So throughout all these steps, you're going to be using the knowledge base built through your graduate education. So what you're doing now will be very good for you if you ever go into engineering consulting. So currently, I work at Rock Science, which is based in downtown Toronto. Our core business is to make 2D and 3D software for civil engineers in mining and geotechnical. So we are based in St. Patrick's Street, and our office has 2.5 buildings. The units are 52, 54, and 54 and a half. So these half units are basically old Victorian era row houses. And on St. Patrick's Street, there used to be a lot of them. Over time, land developers came, bought out the houses and demolished them. So this 54.5 unit is a historical half house that has been spared demolition. So these are the software that we currently have and have been developed over time. There are 18 of these. And when I was a consultant, I used these. These are the audit and analysis toolkit. And broadly speaking, they can be divided into 3 separate categories. So first is you have programs for analyzing slope stability. So you can use the limit equilibrium method or finite element analysis to analyze slopes in soil and rock. The next category are programs for. So it's very common that you may use finite element analysis to look at the stresses and deformations around the tunnel or deep excavation, and also to examine the number of forces in the reinforcements. The last category are analysis programs for settlement and foundation. So for example, you have a deep foundation, you may want to know the distribution of the skin resistance and toe resistance. You may want to know the deflections of a pile beam, for example. Now, we are based in Toronto, but we do have resellers and offices around the globe. And that's because the demand for our software is global. So we need distributors and people to handle technical support at various locations around the world. Now I want to talk a bit more about how civil engineers contribute to the company. Now, in terms of company roles, they can be broadly categorized into a development sector and a business sector. And the people with engineering backgrounds are shown with the bold in the titles. So first of all, we have geotechnical software developers in addition to just software developers. So these are people who typically have master's degrees in civil engineering. And their job is to implement the engineering analysis components into the software. We also have geomechanics specialists. So these are people with PhDs in civil engineering, and they spend their time developing our 2D and 3D finite element analysis programs. And these people are highly skilled. They also provide expert modeling advice to our clients working in finite element. We have the technical support team. These are also people with master's degrees, and they help clients answer their very challenging engineering technical questions. Okay. I want to mention interns. They are incredibly important to your company. And that's because to be on the leading edge in software development, you need to have fresh perspectives. So on the business side, geotechnical sales engineers, they typically have bachelor's degrees in civil engineering, and they interface a lot with clients. They travel a lot to conferences. Now, lastly, at the intersection of the development and business sectors, there are geomechanics product managers, which is what I do. So let me explain that a little bit more. You guys may be more familiar with the term project management. The difference between a product manager versus a project manager is that the product manager manages the product and not the people. Project managers manage the people, budget, and timelines. Okay. So in product management, you are at the communication hub between various parties. So for example, I have to interface with our technological or development team because I have to convey the vision for our products. We should build in the short term versus midterm versus long term. I also have to interface with our customers because we need to know what they think about our software. How are we doing? What are we missing in terms of technical analysis, where we should go? What are the next features we should implement that are important to them? I also have to train them how to use some of our 3D software because it's always harder to do things in 3D than 2D. Now, lastly, on the business side, I have to look at website and sales analytics. I have to know what the competitions are, what the market is like, and also to find collaborators that we can work with to create win-win situations. So now I want to make some comparisons between what you would do in engineering consulting versus what you would do in, let's say, product management for an engineering software company. So let me start with the differences in work schedule. So first, if you are a practicing consultant, you may spend a few long dedicated weeks on certain specific projects. So for instance, you may spend a couple of weeks on the design analysis of a project. On each day, you can spend time doing individual work. We also need to meet with your collaborators to convey some of your preliminary results. You have to have meetings with your clients to convey what kind of methodologies you're using, what are your preliminary results, and what are you doing next. And maybe sometimes late in the afternoon, you may get pulled away in an emergency project that needs to be done ASAP. And I found that's the case on Friday afternoons. You'll also find yourself sometimes in the field, doing field work for an extended period of time. And it can be quite hard because you're working on a different schedule. So I found myself working 7 a.m. to 3 p.m. on site. And there was a time when I had to do field work from 9 p.m. to 3 a.m. That doesn't happen often, but field work is really an essential component to engineering. And then after being on site, I would have to bring the samples to the lab. And sometimes I would have to stay in the lab to observe testing as they happen. And then at the end of the day, I may have to swing back to the office and to document my observations and logs for the day. And that's because your design analysis may be happening at the same time as the field work. I also did a lot of 3D numerical analysis, and these typically happened during normal business hours. But 3D analyses can take a long time. And it's important to make sure they keep running overnight and sometimes over the weekend, so that when you get back in the office, you have results to look at. So this means sometimes dedicating extra hours to this numerical analysis. So typical days of a geomechanics product manager. So here I'm using days, not months. And that's because my tasks throughout the days tend to vary a lot. And my days also tend to differ, right? So some of my typical days, I may be providing technical support. For technical support, I will have various meetings with various people, with my team, with our external collaborators. I teach, which means that I have to prepare for webinars and training sessions. I have to spend time meeting with our UI UX design team to make sure that their user flow designs make sense for engineering analysis. And maybe if I'm lucky, at the end of the day, I'll get to read some literature that's related to the engineering analysis. I may also be spending time reviewing and revising our online documentation. And this is really important because clients need to know what kind of theories or methods we're using in our software. I have more meetings. As you can see, there are a lot of meetings. And then I might spend time interacting with them. And afterwards, it's really important to document their feedback. And then sometimes I will spend an afternoon reporting for our YouTube channel, which is another way that we teach people how to use our software. Okay, so here I'm using two pie charts to show the differences and similarities in the distribution of responsibilities between a consultant versus a product manager. So this black dash line, I'm here to show, so to the right of the dash line are responsibilities that are similar for the two roles, and to the left are responsibilities that are different. So let me start on the right of the dash line, which are roles that are similar for the two positions. You can see that communication plays a huge role for both. And then by communication, I mean writing, presenting, speaking, but especially in a management position, this communication is high. Okay. Now moving on to the next slide, so the gray slide, that's the engineering analysis. In consulting, you can expect to do engineering analysis in the very traditional sense, like your bearing capacity analysis, your pile analysis, settlement, global stability, etc. For product management, I also have to do engineering analysis to support my technical support team. So what I mean by that is the technical support team is there to answer the client's technical questions. But then sometimes clients can ask questions with not obvious answers because they found results from their models that are completely unanticipated. And sometimes our technical team may not know and they may want to confirm something. So then they get turned to me, which means that I have to do the analysis myself and then communicate to our clients how we reach this logical conclusion. So it's just a different way of doing engineering analysis. And I would say that, the writing skills, presentation skills, the engineering analysis that you do in graduate school, these are entirely transferable to consulting and in engineering software development. Now, I want to mention that this pie chart on the left for the consultant may be more applicable to someone early in their careers, maybe in their first 5 years in consulting. Now, as you gain in seniority and move on to become a senior engineer or project manager, you can expect this communication portion to increase, the project management portion to increase, the analysis portion may decrease, and design may also decrease, and field work to decrease because you become too expensive. So for the last part of this presentation, I just want to talk about a project that's being currently undertaken for rock science that I think is pretty cool. So one of the student interns on my team is implementing image segmentation into our 3D software. And for those not familiar with the term, image segmentation is a way of classifying an image into various distinct regions. So here in the original image on the left, it has been segmented into 4 distinct regions on the right. So you can see a distinct region for the wolves, another region for the ground, the third region is for the bush, and lastly for the mountains. So why do we, or how do we use image segmentation in engineering analysis? Well, you can see in this original image of a slope on the right that sometimes the stratigraphy can be distinctly stratified, where each layer represents a different material. So then we can use image segmentation to define the different material regions. So just as a sample dialog. So the first step for the user is to import an original image. In this case, it's a top-down view of the open. The user then has to decide how many materials are on the site. In this case, it's 7. The program then segments this image into different material regions. So there would be 7 clusters. And the last step is for the user to decide what material corresponds to which region. So the idea here is image segmentation provides a very convenient way to define material regions for an area that may be very large and geologically complex. So that was the last slide, and I hope I've shed some light on engineering software development and perhaps a different opportunity within engineering. And if this is something you're interested in, we can discuss further. My business cards are at the front, and I would now be happy to answer any questions. Thank you.
Do we have any questions for our speaker today? Yes.
Yeah, one quick question. You mentioned that you worked for H&GB in the consulting world, and then you transferred to rock science as like a project manager. What were some challenges that you kind of had when you were transferring like the roles, and how did you overcome them?
Right. I guess, well, to answer the first part of your question, which is maybe you were probably wondering how the heck I got into product management when I was in engineering consulting. So to answer that question, before I even went to graduate school, I actually worked for rock science as a geotechnical software developer. So I was doing the engineering analysis. And due to that experience, I know how the coding works. And that's actually very important for a product manager. Otherwise, people working in technology will not respect you. You have to know how the technology works. Second is that with my engineering background, I understood what the software would do, right? So the challenging part about transitioning into product management is that now your role is more open-ended. You're the one talking with people, collecting ideas. It's not like solving problems in traditional engineering where you may start with a set of material parameters. You're trying to get to, let's say, design A, design B, design C, or you can do analyses in different ways. The product management role, you have to think about what direction you want to take. So in that sense, I would say maybe it's a little bit more similar to research than actual practice.
Thank you. Other questions? Yes.
Yeah. Thank you. At the beginning of the seminar we have today, you showed a design of the foundation, telling us that you have a reinforced tiles, right? Now, how do you come up with such? How do you take care of the bending failures and shear failure when the tiles are unreinforced?
I think you're referring to maybe the first slide.
That's right.
Let me go back to that.
Yeah, that's it.
So your question, how did I come up with?
Yeah, I can see the pies. You say they are reinforced concrete.
Yeah.
Now, how do you come up with such? Because I know from the conventional design of pies, they must be reinforced to take care of the bending and shear failures.
Okay, I see where your question is coming from. So just for everyone in the room, the question asked was, why is it in this case the columns are unreinforced concrete? So the specific type of system I was looking at refers to vibro concrete columns. So vibro concrete, these are vibro concrete columns. This is a specific technology where you are mixing the concrete in situ. These columns are not prefabricated externally. Does that answer your question?
Okay.
Yeah. Yes.
Sorry, Professor. Actually, I have a question for the slides after this one. So for this graph, will you use the log slides to get this diagram?
So for my analysis, this was actually using 3D finite difference, which is actually a different software. It's software is flat 3D actually.
Okay.
Yeah.
Because it seems like say or it has some diagrams actually. And actually there is another question, but so this is the real situation for the foundation. I mean the real case.
What do you mean by real case?
I mean the placement of this pile foundation for this kind of job.
Yeah, so this type of system is used. Obviously, the geometry of the column arrays may differ, and the geosynthetic reinforcement at the base, that's another optional feature, but people tend to place 1 or 2 layers of geosynthetic reinforcement to resist lateral tests.
Yeah.
Or at least that's the intent.
So actually for this diagram, I have a specific question like, why don't you use group pile foundation?
This is a group pile foundation. Well, hold on, by group pile, do you mean why is there no pile cap?
Yeah.
Oh, okay.
Because your part is like individual pile foundation.
Are you referring to, can you see my mouth? Okay. Are you referring to the caps for individual piles or the caps for the group?
Yeah, originally I think this is the individual pile foundation, but I'm not sure if it's a group pile.
These caps are for individual columns. Now here you don't see these individual caps. It was just a way to simplify the geometry of the analysis. Yeah.
You mentioned that you've done a lot of 3D modeling. At what point do you think, in your opinion, it's worth jumping to 3D rather than applying in 2D?
So before you jump into any 3D analysis, you should think about whether the problem can be simplified in any way into 2D. And there are situations where you simply cannot, depending on geometry of your model, site conditions, the loading conditions, and boundary conditions. Sometimes it may be best to use 3D analysis, but that depends on your techniques, obviously. But if you can do it in 2D, that can save you a lot of time because 2D analysis is easier to put together. It's faster to run. If you want to do 3D, that's when you know you have to fight the 3D. The most, and sometimes the consideration may stem from the budget. If you're going to be spending so much time on 3D analysis, your project has to have the budget to support it.
Yeah, please can we go back to the other slide? First slide.
First slide?
Yeah.
Okay.
I just want to compliment what my colleague just said now about having like a connection for these individual parts. But I see that the foundation is a bedrock of web soil. So how do you take care of differential settlements in this case?
So how do I?
Differential settlements of the bedrock.
So if your piles are extending to a very complex layer, such as bedrock or friend soil, as I've indicated, usually settlement is not too great a concern. And I think what people would do in this case is that they would figure out the load distribution between the soft soil and the column, and then they may want to do an analysis of the individual column itself. Now, there are cases where the columns may be floating. By floating, I mean that they may not be extending to a competent stratum. In that case, it's actually very hard to do the analysis. People may just resort to numerical analysis. Yeah.
Based on your experience, which software is the best one for analyzing the deep foundation, which is based on finite element method? Is it just FLAG 2D and FLAG 3D, or is another one which is based on finite element?
What are you trying to analyze?
Like settlement information, all those like concerns with.
So for deep foundations, if let's say you're looking at the deformation laterally or the distribution of loads, skin friction and toe resistance, people usually just do a traditional pile analysis. You know, there are like softwares out there like RS pile is one of them, L pile is one of them, A pile, those are older, obviously. But like in our software suite, RS pile uses that. If you were to do, let's say, your QI analysis, which is L pile, RS pile also does that. But if you were looking at some exceptional circumstances, like your pile groups may be very closely spaced together, where you're not sure what your what the PYWs are, then in that case, using numerical analysis like finite element would be very useful.
Rock Science have tutorials for all of their softwares on YouTube. You mentioned that's something that you are involved with.
The tutorials are just documented on the web pages. The videos are some of they showcase some very specific features. I think there are also some case histories. And there are videos that teach people how to construct geometry in 3D space, because that's actually very challenging to do. I don't think, there might be a couple of tutorials.
As kind of like different software techniques get developed, like image segmentation, like machine learning, things like that. Do you ever see like hesitation from like the engineering, like the just pure engineering aspect of things to kind of hesitate to integrate those into the software? Is there ever any pushback to kind of move forward, I guess, with software development?
That's actually really interesting. The technology you speak of, like image segmentation or the same machine learning, they usually support the analysis. They're not influencing the methodology itself. They're just computational methods. So in that sense, users want software that are fast, that are computationally correct. They can do things more efficiently. So from that side, they invest. So in terms of methodologies, we are very careful to only use analysis methods that are widely accepted. Yeah.
Any other questions from the audience?
Hey,
Okay, cool. Thank you all for attending, and let's give one last round of applause. Yeah, next week.
yeah.
Yeah.